Hello everyone, thank you for joining me today in this session. So in this session we are going to be talking about this project on printf. I'm sure at this point you must have been familiar with what printf is. Printf is simply a function that is used to display to the standard output, right? We use printf to print characters, strings, print integers, floating values, whatsoever, okay? And in the last project when we were talking about variadic functions, we said printf is an example of a variadic function because it takes in a variable number of arguments, right? So in this project, what we'll be doing is we are also going to create our own printf function that works exactly like the printf of the standard library. Okay, so that is just what this project is asking us to do. So this is not as complex as you think it is. If you're familiar with pointers and functions, you know how to write functions and pointers. I've stated this when I was talking about functions. I said functions are very, very important. You need to know how to use functions before you be able to succeed in this program. That is, before you be able to succeed in C programming in general, okay, or any program, you need functions. So firstly, you guys need to go through the materials on the intranet. That is the resources they gave you. I'm just going to go straight and explain how to solve these particular problems here, okay? And also, before I continue, there are some functions that we are going to write in this particular project in which I'm not going to write them, or let me say there are functions we're going to need, but I'm not going to write them because these are functions that we've written already when we're talking about pointers. So I cannot write them again and explain them, okay? I will just write the code. Sorry, I will write the codes, but I won't explain them because we've already written those functions when we're talking about pointers, okay? All right, so let's move on. Let's solve examples. All right, so before that, let me give you an overview of my repository here. So as you can see, I have it printf. Oops, I was just even realizing it contains two F's. Anyways, it should be printf. And this repository here that you're asked to create is not supposed to be in the GitHub of all the two members. Okay, only one of you is supposed to create the repository on their GitHub account. Okay, so the other will just be the collaborator. Maybe we're going to see how to do that at the end of this session. Okay, all right, so this task firstly says we should write a function that produces an output, right, according to to a format. So this is the prototype of the printf entirely. As you can see, this is underscore printf, right? So it takes in a const character format, and as you can see by looking at this, this is a variadic function. A variadic function, isn't it? This is a variadic function. So here I already have my putchar.c. Did you see that? I already have my putchar.c, and I've already created my main.h. I have my readme as well. Okay, I already have my readme as well. So now let me open my main.h, or before that, let me open my underscore putchar. All right, so I need to copy the prototype of this. I need to take it to my main.h, right? So I need to paste it here. And also this prototype, that is the prototype of the function. We are not going to create this function now, okay? We are not going to create it now, but we definitely are going to create it, okay? But not now. Firstly, we need to create the functions, okay? We need to create the functions. So now I have this, right? So it says write a function that produces output according to a format. So just look at this. These are the format, okay? These are the format. Let me zoom a bit. Yeah, these are the format: C, S, and percentage, right? So when you see percentage C, what does this mean? When we see C on a printf, we know that we are trying to print characters, right? This is a placeholder we use for printing characters, right? So we are now going to write a function that is going to print print characters, okay? And this function we're going to write here, we've already written this function when we're talking about pointers. Do you get it? So you can give it any name. So let me name mine print. Let me just call it underscore C, right? Meaning for character, right? So let me call it print underscore C.c, right? So what I need to do here now is I need to hash include main.h, right? Main.h, isn't it? So now the next thing is we need to document Betty, and then you need to write the code now that will print characters. So I'm not going to explain how to write this code to print characters. We've already talked about it in pointers. So I will pause the video now and I will write the code, and then we'll move on, okay? All right, so this is the function. This function here is going to print what? Character. Okay, it is going to print character. As you can see, this is the name of the function. I named it printChar. And here, the only difference is that this argument here is what? Of type varList. Because what? The function is what? A variadic function. So I call it varList and I call the argument val. Sorry, I called varList, which is the data type in this case, because it's a variadic function. Then I declare the variable here val. Okay, so that's just the difference between this function and then the ones we've been writing on pointers. So this function here is going to print characters. Okay, it is going to print what? It is going to print character. So what I need to do now is copy the prototype to this function and also take it to my main.h. So vi main.h main.h. So here, let me paste it here. Paste. Right, so now I have this. So now I have a function to print what? Characters. Isn't it? So the next thing is a function to print string. We've also written this function, a function to print string. I can remember we wrote a function to print string as well in pointers. Please refer to the videos we made on pointers. You can get the code from there, or you can, since you've already pushed it to your GitHub, you can copy the code from your GitHub account. It is your code actually. It is your code. So you can copy it and you can paste it here. You can create what? The function to print the string. So just copy them, okay? They are your code. So now what should I name this file? Let me name it print. In this case, let me say underscore s, since I'm printing string, right? See here. All right, so like I said, we already have the code. So what I'm going to do here is I will pause the video as well and I will type the code and then we continue. All right, so this is the code that we wrote to print string when we're talking about pointers. But in this case, there is a slight difference, right? And this is the difference here. In this case, since we are dealing with variadic functions, now we want to create a variadic function because printf is a variadic function. So that's why I'm using varList val here. Instead of using int, a value, or int whatsoever, or char whatsoever, I'm using varList val. This means that this argument here, sorry, this parameter here is what? Expected to hold argument. Right? So that's just what I did here. Okay, I believe you understand. If you understand variadic functions, you'll understand all what I did here. You'll understand the modification I made. Okay, so this function here is going to print string. So let me copy the prototype to this function as well. There is no need for me to explain this. Okay, we've already done this in pointers. If there is any function that we've not done when we're talking about pointers, I will surely explain how to write that function. The reason why I'm skipping the explanation part of this is because we've wrote them already. Okay, so now let me go back to my main.h. All right, so I need to paste the prototype here as well. Just paste. Yeah, so now I have the prototype of print string. So also when you look at this here, I used a function here because we know that when we are to find the length of a string, we definitely, sorry, when we are trying to print string, we need to find the length of that string, right? We need to find the length. Isn't it? And as you can see here, where is it? I called a function strlen. And this strlen, if you can remember, we wrote this function as well during when we're talking about pointers, right? So this is the function that we are going to use to find the length of a string. Instead of using the standard strlen, as you can see here, we added an underscore. This is the same strlen function we created. And the role of this function is to find the length of a string, right? So the next thing we need to do is to get this function strlen. Here we are just calling the function. So now I will go and define the function. Okay, so let me go back, let me create the file, let me call it print, let me call it str.c. right? So here I will now type the code to find the length of a string. Okay, so I'll pause the video as well from here and I will continue after writing the code. Alright, so as you can see here, I now have these functions to find the length of the string. I created two of these functions intentionally. The first one here, as you can see, has what? Its argument, a pointer to a character, right? And the second one here has its argument of what? Const pointer to a character. So it means that if we have characters, just pointers, this function will be able to deal with what? That particular set of characters, or type of characters that are of type what? Char. Okay, while if the str is of type const, if it is a constant, then this strlen underscore c, sorry, strlen c will be called to find the length of a string that is of type const. Okay, that's why I created two. So I'm sure this is not something new. You know how we got this. We wrote a function to find the length of a string, right? All right. So the next thing I need to do is I need to copy the prototypes to these functions and paste it to my main.h, right? So I will just go to my main.h. So there are two of them, right? So here I will paste this, and then the other one is similar or almost the same. So it's just that here in this case I'll have to add c, and here it is of type what? Const, right? So that's the prototype to the functions here. So now I have these prototypes and I have the function to find the length of a string, right? So I'm done with this part, this c here, and I'm also done with s here. So the next thing we're going to do is to write a function that will print percentage. Okay, so I believe this is also something simple. You just need to use putchar and then print what? Print the percentage sign. But in this case, since we've not done something like this before, we're going to explain how the code works. Okay, all right, so let me create the file to write this function. Let me call it print, let me call it underscore, let me say percentage, right? Let me call percentage.c, right? So I need to include my main.h. I'm explaining this because we've not written the function anywhere, right? So this here we are trying to print percentage, right? I'm trying to print percentage, so I need to develop what? The prototype, right? So let me call it print underscore what should I call it? What's the ASCII code for percentage? This is 37, so let me call it print underscore 37, right? So here I will just say void because it is not taking any parameter, right? So here I will say int. Here I will now use putchar to print it. So I'll just have to call putchar here, and then what should be the argument here? I want to use its ASCII value to target this percentage sign, and the ASCII value is 37, so I can just say 37 here. So putchar is going to print it, right? Putchar is going to print it. So at the end, after printing it, I will just say return. Or should I return after printing? Let me just return a 1. Okay, did you see the reason why I added an int here? Okay, you can return anything, but I just decided to return a 1 in this case. Okay, after printing the character, then return a 1, so it means it is off. It is successful, right? It is able to print it. So now we have this. So the next thing we need to do is we need to document Betty. I think that's all we need to do, right? Yeah, that's all. All right, so we are done with this. All right, so let me copy the function prototype as well. Any function you create, don't forget to take the prototype to your main.h, okay? Because if it is not in your main.h, it will not work, okay? So now I need to paste. Oops, I missed something here. So now I have this function prototype here as well. So here with this, I'm able to solve this complete task 0. That's all what we need to do in task 0. Okay, that's all we need to do. We've already created a function to find the length, or sorry, to print characters, which is C. We've already created a function also to print string, which is S. We've also created a function to print what? Percentage. And in these functions, any function that we call or any function that we need, we wrote that function as well. Just like the strlen function to find the length of a string, we wrote the function and we took the prototype and pasted it inside our main.h. I'm sure you understand what we did here. So in this case, we are not asked to handle any precision or any field width. So that's why I just stopped at just writing the code. Don't worry, for now, we are not doing anything complex, but this is just the simple approach, okay? This is how I find it a very simple approach to solve this project on printf. For now, we are not going to write this code, but definitely we are going to write it because it is the main code. It is the main function. It is this function that is responsible for checking which placeholder is passed to printf, and it will call the corresponding function that is responsible to handle such placeholder. Okay, so I'm done with task 0 now. Like I said, we'll definitely come back to this, but for now, I'm done with the task 0. I've written the functions. So for now, you're not supposed to click on the checker. You're not supposed to run the checker here because we've not written this function. The checker will fail since we don't have this. We are following this step by step. Okay, we are going to follow it step by step and see how we can get the solution to this project. All right, so let's go to task 1. It says we should handle the following conversion specifier. So now we need to handle what? D and I. And this percentage D, we all know what percentage D does. It prints integer, same as I. So this D and I does the same thing as well. So here we've also written a function when we're talking about pointers on how to write a function that prints integers. right? So both this d and I have the same function. They have the same function because they basically do the same thing. They print integers. Okay, so now let me create a file. Let me call it print. Let me call it, what should I call it? Let me just call it underscore int, since we are printing integers, right? And there I'll say .c. So like I said, we've already written this function. So I'm going to pause the video and I will write the code and then we'll continue. So this is the function that is responsible for what? For printing integer values, right? And I created two of them. The first one is print int. It is going to print what? I. It is going to deal with this I. And the second one here, when you look at this, let me scroll down. Here, it is what? Print dec. This is going to handle what? D. But everything aside from the prototype is the same. The codes here with the codes in this part here is also the same, because like I said, these placeholders does the same thing. Everything here, everything for this particular function is the same as that of the other function, which is print underscore dec, because they do the same thing. Okay, it's just the prototypes that are different. So now let me copy the prototype and we need to take it to our main.h as well. So vi main.h. So here I will paste this, right? So I will paste this again here. It's just that in this case, it is going to be, instead of int, it is going to be dec, right? So here we're dealing with decimal now. One of the prototype is for D and one of them is for I. So the reason why, like I said, I'm not explaining this is because we've wrote this function. We've wrote a function to print integers. So these are the same functions I'm using here. There is nothing new. If there is any function that we've not write when we're talking about pointers, we are going to talk about it here before we write the code. Okay, so this is just the beginning. Okay, all right, so I believe this is also clear. So I'm done with this part now. Task 1 is done, because when you look at this, you don't have to handle flag characters, field precision, and the length of modifiers. So we are asked not to handle that. So all we need to do is just handle this. So now I've written a function to handle this D and I, isn't it? So that's what we need to do here. So let's move on to the next one. So the next one here, here I believe we are going to write some code here, because I know we've not written any function that converts to binary, right? So it says handle the following custom conversion specifier. This is B here. When you see %b in printf, it means you want to convert it to binary. Whatever you have, it should be converted to binary. That's what they did here. When you look at this, when the underscore printf was called, 98 was passed to it, right? So this is the output we got. So it converted 98 to what? To binary. So now what we're going to do is we are going to write a function that converts to binary. Okay, that's what we're going to do. It convert what? An unsigned int to what? To a binary. So let me name the function vi, let me call it print underscore bin for binary, right? .c, right? So let me include my main.h. main.h. All right, so what should we do now? What should be the prototype to this particular function? We know that it's going to convert an unsigned int to what? To binary, right? So the return value is going to be an integer, right? It's going to return something like this, 1010, something like of this type here, right? So I will just say int. So what name should I give this function? Let me call it print underscore bin, right? For binary, isn't it? So we know that this is going to be what? A var list, because we're dealing with variadic functions, and I will also going to call this var, right? So there are some things I'm sure I'll be mentioning here which would be difficult for you to understand, because they are actually things that are related to bit manipulation, and I don't think we've done a project on bit manipulation yet. So ideally, I think you are supposed to have bit manipulation before this printf, because you are going to be dealing with bit manipulation concept in solving this printf project, but instead bit manipulation comes after printf project. So there are some things here that I'll be saying they might be difficult for you to understand, but I will try my best and explain them. Okay, I'm not going to explicitly explain them because we are not talking about bit manipulation now. Okay, so now the first thing I'm going to do here is I will declare a variable, right? Firstly, we need to understand this. So this is the function prototype, right? So the next thing I need to do is what? I will need to declare two integer variables now, right? I want to declare two integer variables. I will give them any name, and these variables I want to declare, I will all initialize them to 0. Okay, so these variables will be used to keep track of whether non-zero bit have been encountered, and also the other one will keep track of the number of counts of bits printed. Do you get it? The number of bits that have been printed. So here, let me just say int, let me call flag, let me just say equals to 0, right? And the other one, let me call it int as well, let me call it count, right? Let me call it count, and I'll also initialize it to 0 here, right? I'll also initialize it to 0. So here, why did I do this? I said we're going to need two variables, isn't it? So the first one is going to keep track of whether non-zero bit flag have been encountered. That is the 0. Sorry, that is the flag here. And the second one is going to keep track of the number of characters printed. Okay, or let me say number of bits printed. So that's why I declared these two variables here. Okay, so the next thing is I'll also declare more variables. I think I'm going to declare more variables. I think 3 more integer variables, right? So here I will declare I'm going to use this for my looping, right? I'm going to use I for my looping, and then let me declare this one. What should I name it? What should I name it? Let me name it A, and let me say it's cost 1. Why am I creating this? This is going to be used as a bit mask for individual bits. Like I said, there are things I'll be saying it will be difficult for you to understand because you don't have knowledge on bit manipulation, but just try as much as possible to grasp the concept. There are a lot of ways you can write a function to convert to binary, but this is one of the easiest way using bit manipulation. So I declared this variable A because I'm going to use it as a bit mask for individual bits. Okay, like I said, I'm not explaining this explicitly because I'm going to explain it when we begin bit manipulation. Okay, and then I'll declare another variable again. Let me call it B. Why am I using this? I want B to store the value of the current bit. Okay, I'm going to use this for my looping. For my looping, I here as a bit mask, right, for the individual bit, and this B here will be used to store the value of the current bit. Do you get it? So the next thing we need to do is what? We need to call vararg, right? Since we are dealing with variadic functions now, we need to call vararg. And vararg here, we need to pass in var to it. And what again? Before that, let me declare a variable that will store the output. So it's going to be an int. Sorry, it's going to be an unsigned int. Because we are converting unsigned int to what? To what? We are converting unsigned int to binary. Why is it an unsigned int? Because it cannot be negative. Isn't it? So unsigned int, let me call it num for number, right? Let me call it num, and I will just say vararg. I'm calling vararg now, and then I will pass in what? Val, because this is the variable that holds the argument, right? And inside this variable, what data type am I interested in fetching? I'm interested in fetching an unsigned int character, right? So I'll just say an unsigned int here, right? I'm sure you all know what this is. This is variadic functions. I don't need to explain this again. Okay, so I believe this is clear. So I'm also going to declare an unsigned integer variable in which I'm going to use to store a temporary result of bitwise operation. Because this is bit manipulation, definitely we are going to use bitwise operators. Okay, please, you can refer to other resources and go through what bitwise operators are, or just in brief, go and understand what bit manipulation is. Okay, if you understand bit manipulation, you understand what I'm trying to do here. So I just need an extra variable here that will be used to store a temporary result of the bitwise operation in which I'm going to be doing here. Okay, so let me call it what should I call it? It's going to be an unsigned, since we are fetching for unsigned. We are converting unsigned integer, so it's going to be an unsigned what should I name it? Let me call it P. Right, so let me call it P. So the next thing we need to do now is we need to begin the loop. So we need to begin the loop now. So I'll just say for I equals, why do we need the loop? Because this is a variadic function. Val here is going to hold variable number of arguments, right? So we need to loop throughout the argument and look for an unsigned int value, isn't it? So that's why we are going to need a loop here. So what should be the condition to stop this loop? In what condition is this loop supposed to stop? Let me just write it, and then maybe some of you might have an idea of how this is going to work. Why do I add this less than 32? So why is this condition I less than 32 here? In fact, what does this loop does entirely? So this starts a loop that I iterate 32 times. Okay, that is from 0 to what? To 31, right? So why is it 32? Because 32 corresponds to the 32 bits in a 32-bit unsigned integer. That's why we're using 32 here. unsigned integer has what? 32 bit. So that's why here we are using 32 bit. Okay, like I said, this is bit manipulation, but in fact this is not even bit manipulation. Unsigned, you must have known this already when we're talking about variables right from the beginning of this particular program, right? So this is the use of this loop, right? So what should we do inside this loop now? We need to calculate a bit mask. So if you remember, we said this P is declared to store the result of the temporary bitwise operator, right? So the next thing we need to do now here is we need to calculate a bit mask of P here, because this P here is going to hold what? A temporary result of the bitwise operator, right? So I need to calculate a bit mask P by left shifting the value of A. I hope you remember what A does here. We are going to left shift the value of A by 31 minus I. Why is 31? Because this is going to stop at what? Less than 32. That is 31, right? So at 31 minus I. Okay? Alright, so the next thing I'm going to do here is just look at me, okay? Just look at it. I'm just going to say P, right, is equals to A asterisk, less than, and what again? I will just say 32 minus I. So what does this mean? Here I'm trying to calculate a bit mask P. I'm sure you remember what P does. We said it's going to store the temporary result of the bitwise operator, right? So I'm just saying that I want to calculate the bit mask of P by left shifting the value. This simply means left shift. Like I said, we've not done bit manipulation, so this might look confusing, right? This is going to left shift it by the value of what? A by 32 minus I position. Okay, that's just what this is going to do. So I need to also what? I need to perform a bitwise AND on this operation. Okay, I need to perform a bitwise AND. So what is the sign of a bitwise AND? This, and then I will pass a num here. So what I did here is I just calculated a bit mask P by left shifting the value of A by 31 minus I position. Okay, and after doing all this shifting, sorry about this, after doing the shifting, I'm performing what? A bitwise AND on the operation together with what? With num. Like I said, I'm not going to explicitly explain this. This is bit manipulation, so let's not go into that part for now. Okay, so that's just what I did here. Okay, so this operation isolates the bit at position 31 minus I. That's just what this does. It isolates the word bit position at 31 minus I. Do you get it? So what's the next thing we need to do now? The next thing we need to do here is we need to pass this condition that checks if the bit at position 31 minus I is 0 or not, because we are looking for 0 or 1. Here we already set what? A to be equals to 1. So it means here we are going to now be in lookout for what? For 0. So the next thing I'm going to do here is if my P here is right shifted to 31 minus I, right, 31 minus I, then I will just say flag here is equals to what? Is equals to 1. So what does this do? This checks if the bit at position 31 minus I here, this, right? This checks if the bit at this position is set in the bit mask P. That is if it is non-zero. Okay, if this is set, it means that there is a non-zero bit encountered in the remaining bits. So this way it will set the flag to be equals to what? To be equals to 1. Okay, that's just what this does. Okay, so now the next thing we need to do is to check the flag itself. That is if the flag has been set. We know that this flag is only going to be set if a non-zero has been encountered, right? So all I'm going to do here is I'll just say if flag, that is if it is not false, that is if it is not 0, because flag has already been initialized to be 0 here. So if it is not 0 here, indicating that what? A non-zero bit have been encountered, right? So what should we do? I'm going to pass in this condition here. I'm going to do something like this. Sorry, this should be this. All right, so the next thing I'm going to do is I will calculate the value of the current bit, right? I'm going to do that by right shifting P by 31 minus I position. Okay, and this variable here B is responsible for holding the value, right? Or let me say the result of the calculation. So like I said, I'm going to right shift it by 31 minus I, right? So I will just say B in this case is equals to P right shift 31 minus I. Okay, so now I'm done with this. So the next thing we need to do is to print the current bit at that position. Is it a 0 or is it a 1? Right? So we're going to use putchar to print it. So here I will just say putchar, and then I will pass in what? B plus what? You can say plus 48. This is the ASCII value of what? Of 0. So I'm trying to convert this. B here is holding an integer. Don't forget, we've declared it as an integer. And we know that putchar cannot print it unless it is converted to a character. So you can add 48 and you can add 0 in a single quote. Anyhow you do it, it is going to work. Okay, so the next thing we need to do here is what? After printing it, don't forget we are going to keep track of the number of arguments that is printed or number of bits that is printed. So don't forget we declared this variable to store the number of bits that are printed. So it means after printing this bit here, we need to increment the value of count, right? So I'll just say count plus plus. I wanted to write count, but I misspelled it. I don't want to go back there and make the correction. So this is simply how to do this. So now I've checked for the flag. So that means if the flag is what? A non-zero, it means that what? A bit has been encountered. So this means that if the flag is set, it means what? A non-zero has been encountered. So that's when we are going to do all these things here. Okay, I believe this is clear, right? All right, so after this loop finished running, right, we need to check whether any bits were printed, isn't it? So if no bits were printed, that is our count here, it still remains what? Still remains 0. Right, because we've initialized it to 0 here. So it means if there is nothing printed here, then count will not be incremented, right? So it will remain as what? It's 0. So I need to pass in this. If count is equals to 0, right? So if it is equals to 0, it means that what? Nothing is printed, right? Count is still 0, right? If it is equals to 0, then we need to increment count to 1 now, right? If it is equals to 0, we need to increment count to 1. So I'll just say count plus plus. So after the incrementation here, I will now print what? A 0, right? Because count is 0 already, right? It is 0, so I'll just say putchar, or let me call my underscore putchar here. I'll say underscore putchar, then I'll pass this. I know this is confusing, okay? This is bit manipulation. We are doing more of bit manipulation here. And because you're not familiar with bit manipulation, that's why you'll be having difficulty understanding this. But on your own, you can utilize external resources and check for bit manipulation. You'll understand what I'm trying to do here, if not all, but most of it. Okay, so the next thing we need to do is we need to return our number of characters printed. So I'll just say return count here. So this way I will have my binary, my unsigned int converted into binary. Okay, as you can see here, it is returning the number of argument printed. Okay, so now this function here is going to convert an unsigned int to what? To a binary. That's what this code is going to do here. So the next thing I need to do is I need to document Betty, right? So let me document Betty. So I'm done with Betty documentation. So let me copy the prototype as well and take it to my main.h. all right, so here I will paste this. All right, so this is what we're expected to do here. Now we've wrote a function that will handle this %b here. Okay, we've wrote a function to handle it. In fact, now we've not connected any of this function with any of these placeholders, either the b or the I or the d. We've not made the connection. Now we are just writing the functions that when the printf sees b, it knows which function to look for. Now we are just writing the function. It is the most difficult part of this project, writing the functions. After writing the functions, you'll be able to do the remaining without having any problem. So now technically we are done with task 2. Okay, we are done with task 2 now. So like I said, we are going to test this after we wrote all the functions. Okay, after writing all the functions, we are going to test this printf. Okay, so now let's move on to task 3 of this project. Alright, so this task here is asking us to handle these following conversion specifiers. When you see %u in printf, it means what? We are trying to print what? An unsigned int, right? When you see o, it means you are converting an unsigned integer to what? To octal, right? Octal representation. And when you see this small letter x, it means you are converting to what? Hexadecimal. But from the values of 10 to 15, that is from A to F, right? It should be in what? In lowercase alphabet. While this is the same conversion, but in this case uppercase. Okay, we know 10 is represented using A and 11b, 12c, 13d, 14e, and 15f. That's how they're represented in hex, right? So these values that are represented using alphabet should be what? Should be displayed using either a small case a, that is if percentage small x is used. If percentage capital case x is used, then we are expected to print those alphabets in what? In capital case. So this unsigned int here, we've already written a function that is going to convert or print an unsigned integer. It is the same thing as the d and I we wrote here, this function. Yeah, this function d and I, it is the same thing. So I've already copied this particular code for this d and I've copied the code. So all I'm going to do here is just I'll create a file for this unsigned int now. So let me call it print, let me just call it unsigned, right, .c. So all I need to do here is just paste the code. I have it copied already. Like I said, it is the same. So when you look at this here, this is the exact same code for what? For I. As you can see, even the function prototype here. So it is the same thing. Like I said, the code is the same. So all I'm going to do here is I will just vary this prototype a bit so that it will be differentiated from that of I and that of you. So here I will just say unsigned. So since this function is for unsigned int, so now I have a function for this. So I will now copy the function prototype and I will take it to my main.h, right? So vi main.h. So I will paste it here, right? Paste. All right, so now I have the function prototype here. So I'm done with what? With this u now. Okay, I've wrote the function for this. So the next thing is the octal. So how do we convert to octal? First, let's begin to understand how we convert to octal. Octal simply means 8. Okay, octal simply means 8. So assuming I have this value, let's say 68. Sorry, my screen. Let's say I have 68, right? I want, sorry, this is very poor. Let me just use the brush. I think it will be better. Yeah, if I should say 68, the problem is from my screen. Okay, I want to convert this using octal, right? I want to convert it to octal. This is in what? Decimal, right? How do I convert this to octal? So all I need to do is I'll do something like this. Here I will just put R, which stands for the remainder. So all I'm going to do here is you divide 68 by 8, right? When you divide 68 by 8, you are going to get 8, right? Just 8 times 8, you are going to get what? 64, isn't it? So what is the remainder? We have 4 as the remainder, right? So the remainder here is what? Is 4. So I'll put my 4 here. So the next thing is I will divide this 8 again with another 8. So 8 divided by 8, it will give me what? 1 here. Right? So what will be the remainder? There is no remainder here. Right? So the next thing is this one here now. Since it is not 0, I need to divide it by 8 again. So if I divide 1 by 8, we used to say it will not go. 1 divided by 8, this will give us what? A 0, and then the 1 will be a remainder now. Right? So now I have converted what? 68 to octal. So what is the octal value of 68 now? So now we then start taking our value from what? From the MSB. This is the most significant bit to what? To the least significant bit. So we start from this bit here, the MSB. So what should be the value now? We have 1, and then the other value is what? 0, and then the other value is what? Is 4. So 104 here is the hex value for, sorry, 104 here is the octal representation of 68. You can punch your calculator and you find out, okay, or you can do the conversion. So 104 is what? Is the octal representation of 68. So this is how you convert from a decimal to what? To an octal value. Okay, this is how you convert from decimal to octal. So I'm just trying to explain the concept of the conversion because we need this concept for us to be able to develop the code. Okay, I believe you understand this, right? All right, so let's move on and let's write the code. Let's see how we can be able to come up with the solution to this. Okay, so the first thing I'm going to do here is I need a loop, right? Or before that, let me create the file. Let me call it, this is octal, right? So let me just say print oct. Yeah, let me call it, I think this is okay, right? Octal.c. So I need to include, I just remembered I've been using the std ag libraries, sorry, functions, that is the standard libraries, var list and var ag. I've not included the standard library in the main.h. I just hope I should remember doing that before compiling this program. All right, so main.h, right? So let me give it a prototype int. So what shall I call it? Since we are dealing with integers, right, I'm expecting this to return an integer value, so that's why I'm adding the return value to be an int. So let me call it print, what should I say? Let me call it oct, right? So print oct. So I will just say var list. It's going to take variable number of argument, and I'm also going to call this val again. All right, so what do we need to do now here? The first thing we need to do is, we know that we are going to need a loop, right? We're definitely going to need a loop to loop over what? Val, to loop over the argument, right? So I will declare the variable I'm going to use for the loop, let me call it I, right? So I'm also going to need another variable, and this variable is going to keep track of the number of octal digits. When you look at this here, this example I just gave here, how many octal digits do we have? We have 3. That is 4, 0, and 1, right? We have 3 digits here. So I'm going to need a variable to store the number of digits, the octal digit. So I'm going to call it, let me just say counter, right? It's going to count, right? So I'll initialize it to 0. Sorry, so initialize to 0. So I initialize counter to 0. So the next thing we're going to do here is, I need to what? Call vararg, right? Vararg is responsible to get, so vararg is responsible for getting what? These values that I want to convert to what? To octal, right? So I will now say unsigned. I want to store it in another variable, okay? So unsigned, let me call it num, and I will now call my vararg here. So vararg, what variable am I looping over? I'm looping over val. And what am I looking for? I'm looking for any number of unsigned integer as its data type, right? So this will look for all unsigned int inside this val here. So when it gets it, it's going to store it in num here. Okay, it's going to store it in num. So the next thing I'm going to do here is, I think that should be, or maybe we can start doing something now. All right, so firstly, this num here is going to hold the number that we want to convert to octal, isn't it? So I first need to check, can that number be divided by 8? That's the first thing we did here. We divided the number by 8. What if the number cannot be divided by 8? That is, in the first instance, what if it cannot be divided by 8? So it means what? It can't be converted to octal, isn't it? So how do we do that? So firstly, what I'm going to do is I will set a loop. I will say, as far as my num, right, when you divide it by 8, as far as it is not equals to 0. If it is not equals to 0, it means what? It's not up to 8, right? It's not up to 8. If you divide 8 by 8, what do you get? You get 1. Just take note of the operator I use. It's a divisor operator, not modulo. So I'm not considering the remainder now. 8 divided by 8 is 1, right? If 8 divided by 8 is 1, so it means what? This number here is divisible by 8. So it means we can find the octal value of this number. If it is equals to 0, it means num is less than 8, right? So let's assume num is 7. So when you divide 7 by 8, what will you get? You get 0 point something. So, and here we are using the divisor operator, so it's going to get 0 for us. So therefore, it is not going to go into this loop. So this num here will not be divided by 8. So that's what I'm going to do here, right? So if it is divided by 8, and when it's divided by 8, as far as it is not equals to 0, it means what? It is a divisible of 8, right? It can be divided by 8. We can find the octal value of that number. So I will now update my value of num. So I now say num is now equals to what? Num divided by 8. So what I just did here is I checked. It can be divided by 8. Okay, so since it can be divided by 8, I want to divide the number by 8 now. Since it can be divided, okay, then divide it. So after dividing it, store it inside num. Okay, that's just what I did here. So after, the next thing we need to do here is, we said we declared a variable counter which is responsible for holding the number of octal bits, isn't it, or octal digit. So I will now say counter plus plus. Why am I incrementing counter here? Because we have what? Found one octal digit, isn't it? We found one octal digit. Now I'm talking about for the first instance of the loop. Okay, if it divide this by 8 and stores the value in num, then increment counter plus plus. Increment counter instead. Okay, so now we found what? One octal digit. So that's how it will check again. It will now come here. The value of num, don't forget, it has been updated now, right? So num divide by it again, it will check, is it equals to 0? If it is not equals to 0, then it means what? It can be divided by 8. We can find what? The octal value of that number, right? So it will jump into the loop again, and it will divide the number by 8. After dividing it by 8, it will store the new value of num. That's how it will keep going. So this loop is going to continue until the value of num is 0 or the value of num is less than 8. Because if it is less than 8, then it cannot be divided by 8. So we can't find the octal representation of that number. I believe this is clear, right? So here I need to add my counter plus plus again. Why am I adding this counter plus plus? I'm adding this because I want to account for the last digit of the octal representation. Okay, so this will provide an extra space, or should I, since I'm not allocating space now, I will not say space. It means that it's going to consider including the last digit of the octal representation. Okay, so the next thing I need to do here is I need to use malloc. Since I have these digits now, the octal digit, I want to store them in an array. Okay, I want to store them in an array. So I think I need to declare an array here. If you've remembered your malloc, you know that for you to use malloc, you need a pointer, right? And what are we storing in this array? We're storing integer values, so I'll just say int, and let me call it array, right? So I'm storing array inside this. So what's the next thing I need to do now? The next thing I need to do is I need to declare, or I need to call malloc to allocate memory for me to store the content inside this array, right? So I'll just say array is equals to what? Malloc, right? Size of, what am I storing? Integer value, right? Size of int times what? So what should be the value here? Don't forget, counter here is responsible for counting the number of digits, right? So it is exactly what counter is holding that is the amount of digit we want to store in the array, right? So here I'll just say what? Counter times counter. So what if counter is 5? So I'm going to store what? 5 integers in this array. Right? That's just what this means. 5 integer in this array, because counter counts the number of digits. So what do we do when we declare a variable? Sorry, when we call malloc, if you can remember, we need to check, right? If malloc, if array is equals to null, that is if malloc fails to allocate the memory for us, right? So what should we do? We normally return a null, right? If malloc fails, we return null. Isn't it? So else, what do we do? Now the next thing we need to do is this digit that we have, this octal digit, we need to store them inside the array now. Now memory has been allocated for the array. So now store the digit. It means, this digit here, this 104 that we have here. Now it's time for us to store them inside what? The array. Isn't it? Or let me say this 401 here. This 401. Now we have to store them inside the array. That is the memory that malloc allocates for us, right? So I will need a loop to do that. I'm sure this is not something new. For I equals to 0, it means I'm starting from the index 0 of the array, because this is an array, right? So what should be the condition? How many characters or how many items am I storing in the array? I'm storing counter number of elements, right? If counter is 5, I'm storing 5 elements. So but since I'm starting from 0, it's going to be what? Less than counter. Isn't it? So 0 to 4 is going to give you 5. This is not something I should be explaining, right? I've already done this. So I plus plus, right? So this will loop over the array. I'm expecting this to loop over the array. So for each iteration of the array, I want to store the digit, right? The octal digit. So all I'm going to do here is I'll say array index I. Now I'm targeting each index. For each iteration, I'm targeting the index. Or before this, let me do something here. Let me declare an extra variable. I'm going to need this variable to hold what should it hold? I'm going to need it to hold this unsigned int. Let me call it temp. For is a temporary variable. I just want to say num. I just don't want to tamper with this num here. Okay, I don't want to tamper with this. So I created an extra variable to hold the same num here. Okay, I call it temp, just for temporary. You can name it anything. So here, array index I. What I'm trying to do here is I want to now store the remainder, because when you look at this, for each of these, what are we interested in? In getting the remainder. We're interested in the remainder, right? And how do we get remainder? We take modulo. isn't it? So here I will just say TEM, that is what I'm indirectly targeting my norm here, right? So TEM modulo what? Modulo 8. We are dividing by 8. So now I'm storing the remainder now inside array because it is the remainder I'm interested in. Okay, so now I'm storing the remainder. So now for the first iteration, we have 4 stored inside what? Inside this array, right? So after storing this, we need to update the value of this TEM, right? Or let me say temporary, right? We need to update the value. So how do we update the value? Just like the way we did here, we divide it by 8, right? So here I'll just say temp is equals to now temp divided by 8. So it will divide the value of temp by 8 again, right? After dividing it by 8, it will update the value of temp. So the loop will come again, and then this condition will be checked again. Sorry, not this condition. This particular line of code will be executed. That is array index 1 now, right? It will check whatever the value of temp is. It will divide it by 8 and check the modulo. After storing the modulo, it will update the value of temp again. So that's how the loop will keep going as well. The loop will keep going until the condition becomes false. Okay, so this loop is simply created just to store the octal digit in this array. Okay, so the next thing we need to do here is what? Now we have this digit stored in array, but they are going to be stored in this format, right? As you can see, we store 4 before 0 before 1, isn't it? So they are going to be stored like this in the array 401, right? And this is not how we are supposed to print it. We are supposed to print it from the word, from the most significant bit, which is this last digit here. So we are supposed to have 104, just like the way we did here. So it means whatever we have inside that array, we have to print it in reverse now. So we are printing the element of an array in reverse order now. That is the next thing we need to do. I'm sure I remembered we wrote a function when we were dealing with pointers on how to print the element of an array in reverse. So that's exactly what you're going to do here. Okay, I hope you understood why I'm printing this in reverse, because like I said, just like the way we did here, we are printing from the most significant bit, right? The last character here, or the last digit here, right? But in the array, what we just did in this code, it is just storing them in what? From the LSB, the least significant bit. So it's going to store from 4, 0, and 1. So now it's time for us to print in reverse. Okay, that's also what we're going to do. So what I'm going to do here is I will create another loop. So for I is equals to, so now where do we start this loop? So in this case, we are starting from the last element, isn't it? We are starting from the last element. Don't forget, this is stored in an array format, right? It is stored in an array format. So we have something like this. Let me just try to demonstrate this here. 4, 0, and 1, right? This is index 0. Sorry about this. Index 1 and then index 2, right? Index 0, index 1, index 2. So here we have 4, and here, well, let me just delete this. Okay, let me delete this entirely, and let me do this. We have 401, right? This is what we want to print in reverse. Oops. Yeah, so this is 0, 1, and 2, isn't it? This is 0, 1, and 2. Index 0, index 1, index 2. So how do we target this last digit here? Since we are starting to print from here, I'm not supposed to explain this, but let me just explain it quickly. How do we target this last digit here? To target this last digit, it means we need to find the length of this string. After finding, the length of this array, the number of elements in the array. After finding the number of elements of this array, then you minus 1. In this case, what is the number of elements here? We have is 3, right? So it's going to be what? It is going to be, so it is going to be 3 minus 1, which will give us what? 2, right? So what is in index 2? Index 2 is holding the last digit. So that's how we get the last digit. We simply need to what? Find the length of the elements, or find the number of elements in the array and minus 1. That's how we get the last digit. Okay, so here in this case, we don't need to find the length because counter here is already holding the number of elements in the array, right? So I'll just say counter minus 1. So I'm starting from counter minus 1, now the last element. So and the condition is going to be I has to be greater than or equals to 0, because we are starting, the last index we are going to deal with is what? Index 0. So it has to be either greater than 0 or equals to 0. Okay, then in this case we are going to decrement instead of increment, right? Since we are printing a reverse. So inside here now, I can now use my putchar function to print the value. So I'll just say putchar here, and then I will pass in what I want to print. I want to print whatever is at index I now. Array index I. Sorry, where is it? Yeah, array index I. I want to print whatever is at that position. And we know that putchar cannot print a digit. And here we are dealing with digits, so we need to convert it to what? To a character. So this function here, or this loop here, is going to print it in reverse. Okay, so now the next thing we need to do here is we need to free the memory allocated by array. Right? We know that whenever malloc allocates memory for us, we need to free the memory. So here I'll just say free, and then I will pass what? Array here. Okay, I will now pass array here. So the next thing I need to do here is I need to return counter. Right? That counter here, you're seeing here, is holding what? The number of characters. Sorry, the number of octal digit. So we need to return it. So I'll just say return counter here. So now I have this function. This is simply a function to convert an unsigned int to what? To an octal value. Okay, so now the next thing we need to do is let's document Betty. All right, that's simply what we need here. Okay, so now let me copy this, and I need to take it to my main.h as well. So vi main.h. So I need to paste this here. Okay, so paste here. Okay, int. All right, so now I have the prototype as well. So now we've written a function that will what? Convert to octal. We are done with what? Unsigned. We are done with octal now. So the next thing is we are going to write a function that converts to hex. So conversion to hex is the same thing, or let me say is similar to conversion to octal. It's just that in this case, instead of dividing by 8, you divide by what? By 16. I'm sure you understand what we did here earlier. We divided the number we are converting by 8, right? And we take note of the remainder. So in this case, if you're converting to hex, you divide by 16, not 8. Divide by 16 and you take note of the remainder. So I'm not going to do this, okay? Because, yeah, like I said, it's just similar to what we did previously. Just divide it by 16 instead of 8. Okay, so what we're going to do now is this. What should we name the file? Let's call it, no, let me just say print, this is hex, right? So let me call it hex, yeah, .c. I think it's okay, right? So let's include our main.h, right? So let's develop the prototype now. So I'm converting to hex. I'm dealing with integers, right? So I'm going to say int. So let me call it print hex, the function name, and then what? Var list, variable number of argument, and val here. Let me just document my Betty here. Okay, before. So now I have this function prototype. So like I said, everything we're going to do is the same thing as what we did earlier. Okay, so I'm going to pause the video and I'm going to write the code up to the point that the code is different from the previous one. Okay, and then we continue. All right, so this code here is similar to that of the octal function we wrote. Okay, so it's just that the difference here is that in this case we are dividing by 16, not 8. I've already explained that. So anywhere there is 8, as you can see, I'm replacing it with what? With 16, isn't it? So here comes another difference inside this for loop here. Don't forget, this for loop here is simply used to what? To store the digit inside what? This array, right? In this case we are dealing with hex, so the hex digit inside this array. So now we need to print the what? The digit in reverse. Okay, whenever you're trying to convert to binary, octal, or whatsoever, after finding the remainders, you print them in reverse. So how do we print this in reverse? We are supposed to say putchar, just like the way we did earlier. You can just say putchar array at index I, right? And then we say plus what? This, because we need to convert it to character, right? Because putchar cannot print character. But if we do something like this, it's not going to work entirely, because we know that in hex, the value 10 is represented using A. The value 11 is represented using B. the value 12 represented using C, the value 13 D, 14 E, 15 F. So from A to F, we need to put that into consideration as well here. And there is no place we consider that in our code here, right? So what I'm going to do here is I need to set an if condition here, right? So I need to check if whatever is at that index of array that I want to print, if it is greater than 9, that is starting from 10, right? If it is greater than 9, then we need to convert it into what? Into a character, sorry, into their corresponding values, right? We need to convert it into what? Into their corresponding value. So before this, let me explain something. Assuming what is in this index here is what? Is, let's say, 10. Whatever is in array index 9 is what? Array index I is what? Is 10. Assuming I have this, let's say I have 10 as what is in that position, right? So I want to convert this to its corresponding value, or its corresponding alphabet, right? I want to convert this to its corresponding alphabet. This is 10. So we've already developed the pattern to convert this to its corresponding alphabet, right? So we simply need to add what? 39. So if you add 39 to 10, what will you have? You will have 49, isn't it? You will have what? 49. So here in this case, this is just saying that, okay, here I'll just say array index I'm trying to convert it. Okay, I'm trying to convert it here. So it's equals to what? Array, right, at that index, but here I'm going to add what? 39 to it. Okay, so like I explained in this case here, I said assuming whatever is in this position here, array index I is 10. So you add 39 to it, is going to become what? 49, isn't it? So now we have 49. Up to this point here, we have what? Array index I as 49, isn't it? But here in this case, what is array for index I? Array index I here is 49. At this point, array index I is 49 because of what? The computation here. So when you add plus 0 to it, what is the ASCII code of this 0? The ASCII code of 0 is 48. So this is going to be what? 49 plus what? Plus 48. Isn't it? That's going to be 49 plus 48. So when you add 49 plus 48, what will you get? You are going to get what? 97, I believe, right? You are going to get 97. So what is 97 representing in the ASCII sheet? Let's check the ASCII sheet, please. 97. So let's look for 97. So as you can see, 97 is representing A, isn't it? 97 is what is representing A, right? 97 is representing A. This 10 here is representing A, right? It means in hex, I'm talking about hex in this case now. A, 10 is A in a hex, 11 is B, right? 12 is C. That's how it goes up to 15. So now it means I have converted this to what? To its corresponding hex value. Assuming this is what? Let's say 12. Now 12 is representing what alphabet? 12 is representing the alphabet C, right? Alphabet C. So if we add 39 to this, what will we get? We are going to get what? 51, right? 51. So 51 plus the ASCII value of 0, which is 38. Is it ASCII value of 0? Is it 38? Let me just check this and confirm, please. ASCII value of 0, 0, 0. Okay, 48, not 38. So plus 48, right? Plus 48. So we are having 51 plus 48. So this is going to give us what? 99, I guess, right? Yeah, it is 99 actually. So this is going to give us 99, isn't it? So what is representing 99 in the ASCII sheet? Let's see. 99, where is 99? 99 is C. Did you see that? It is what? It is C, right? So it means this is correct because 12 here is representing C, right? And now we have successfully converted it to what? To its corresponding ASCII value now, which is 99. So that's why I'm adding what? 39 at this place here. I've already developed the pattern to add 39. Okay, so this is simply how you convert to hex. Okay, so after this, we do the same thing. Here we need to free the memory allocated for us. So free, I will pass in array, and after printing the array, freeing the array, then what? We need to return our counter as well. Okay, so we are done with this. That's simply what we need to do here. So here in this case now, when you look at this, this is also conversion to hex, but in this case it is converting to what? We are dealing with what? Capital cases, right? When you look at this conversion here, 99 is what? ASCII code of small letter C, isn't it? 99 is ASCII code of what? Small letter C, and 97 is the ASCII code of small letter A. So now we are dealing with what? Small letters here, right? The representation of 10 to 15 in small letters. So now we need to consider the representation in capital letters. That is from what? 65, right? So how do we do that? That is for this part here, okay? So the code is the same. The code is the same. So I'm just going to copy this here, and then, oops. I'm just going, before that, I need to copy the prototype here. So I need to take it to my main.h, vi main.h, right? So that's how we keep doing this. We keep writing functions. Okay, all right. So let me open the file again, and I need to copy this because, like I said, the code is the same. It's just a single line of code that we need to make changes to. So let me call this print. In this case, I'm going to use capital hex instead of small hex.c, right? So here I'll paste this. So the difference is at this point here, this point. So here, instead of saying plus 32, or sorry, plus 39, we are going to say plus 7. That is the pattern for this. And let's test this now. Assuming what? This I here, the array index I is holding, let's say 13, right? So 13 plus 7, we are going to have exactly 20, right? 13 plus 7 is 20. 13 is representing what, please? A is, we know, is 10. B is what? 11. C is 12. D is 13, right? So this is going to be D, isn't it? This is D. So this is going to give us 20. So 20 plus the ASCII code of 0. Where do we get this 0 from? This conversion here. Sorry, this putka here, using this plus 0 here to convert it to character, right? So we add what? Sorry, not this. We add plus 48, isn't it? So this is going to be plus 48. So 48 plus 20, this is going to give us what? 68. So let's see. Let's check the ASCII value of 68. Is it going to give us D? Is this going to give us capital case D? Let's check. 68, right? Let's check where is 68. Yeah. So did you see 68 is what? Is the capital case D. So now this is how we need to convert what? To hex. So we've seen that to convert to lowercase characters of hex, we add 32, right? And to convert to uppercase characters of hex, we add 7. Isn't it? In the previous one, we add 32. In this case, we add 7. And everything here is the same. So here I just need to make changes to this code. Instead of saying the prototype, instead of using lowercase hex, let me use caps hex here. I think this is okay, right? So here I need to change this as well. So this is going to be this. So please, if there is anywhere I do not make this correction, and Betty, please do it on your own. Okay, I might forget, and if you don't make the correction, you'll not pass the check. Okay, I believe this is clear, right? All right, so let me copy the prototype and take it to my main.h. So vi main.h. All right, so we are beginning to do something now. Okay, don't worry, I'm sure you want to see how this function works. We are going to see how it works. I just want us to finish writing all the functions. It will be easier for us. Okay, not all actually, just what we can. Okay, so here I need to include, I've used malloc, right? So I need to include stdio.h. That's not for malloc, but I need to include that of malloc as well, which is the stdlib.h. I also need to include that of the periodic functions, which is the stdarg.h as well, isn't it? So now I have this, right? So now I have these functions, isn't it? So now we are done with task 3. Basically, we are done with task 3. We are writing the functions like I said. Okay, so let's move on. Task 4 says use a local buffer of 1024 characters in order to write as little as possible. Don't worry, we are going to do this when we begin writing this main function here. This main function, we are going to do that. So for now, we're going to leave it. Alright, so task 5 here says we should handle the following custom conversion specifier as well, which is this S here. So this S here, as you can see, it is in a capital case, right? So it says print the string. So this is also a placeholder for printing string, but it's a bit different with that of the lowercase s. And let's see, it says non-printable characters 0 less than ASCII value less than 32 or greater than or equals to 127 are printed this way. Okay, let me just zoom out a bit. Yeah, it says are printed this way. So in your ASCII sheet, values that are less than 32 and are also greater than 127 are non-printable characters. You cannot print them. Just have a look at your ASCII sheet. You cannot print them. They are not printable. Okay, and they said what? They are printed this way. You add this /x. They are telling you how you can do that now. Okay, how to print them. You add this /x followed by the ASCII code value in hexadecimal. Okay, followed by the ASCII code value in hexadecimal. Take note, not in decimal, in hexadecimal. And it says uppercase hexadecimal. We've seen how to write a code to convert to hexadecimal. We considered lowercase and also uppercase. So here they said uppercase. Always 2 characters. So it says always 2 characters. All right, let's see what this is trying to ask from us. When you look at this one, the function is being called here. %s is passed, right? And this is the string that is passed to it. As you can see, we have best and then /n. So this is what a non-printable character. You cannot see /n, isn't it? Just that we know that it's just used for spacing. Sorry for moving to a new line, right? So in this case here, this /n, it should be replaced with what? Or it should be printed like this. You should print a / and then print an X. Do you get it? So just look at this here. Did you see that after printing best, what was printed? / and then what? And then X, right? So after printing it, it says what? In hexadecimal, uppercase, then it says always 2 characters. Always 2 characters. So as you can see here, this is 0 and this is A. So this is the 2 characters they mean. Okay, what is A? A in hexadecimal, we know it is 10. It stands for the value 10. Right? So instead of putting just A, you need to add what? 0 before the A. So this way we have it in what? 2 characters. That is just what they are trying to, they're asking us to do now. Okay? I believe this is clear. So one thing you need to understand is, let me open my ASCII sheet. I'm sure you'll be thinking, why do we have 0A here? 0A here is the hex value for what? For /n. Okay, let me just open my ASCII sheet. Let's look for 0A. Did you see 0A here where my cursor is? 0A. I believe you can see it, right? This is it. Where is it? 0A, right? So as you can see, the value, the decimal value is 10. So 0A here is the hex value of what? LF. What is LF? LF means line feed. So that is the /n. Moving to the next line. Okay, that is line feed. So that is LF. So the hex value of LF is what? Is 0A. So that is why here in this case you are seeing 0A, because 0A is the hex value of what? Of the value that cannot be printed, which is this /n. Okay, so now we are going to write a function that is going to handle this %s. Okay, so what should I name it? Let me call the file, we are going to deal with s, right? So let me just call it print underscore. I already have a file name string, right? Let me check. I think I already have a file name string. Okay, yeah. So let me call it, I don't even know what to call it. So print, let me just call it xc. Then let me just say string. That is exclusive string. Okay, just exclusive string. Since we are not printing everything, there are some things that we cannot, or we are not going to print. All right. So I'm going to include my main.h. Right, and then what? So let me give this a prototype, right? We need to give this a prototype. So we're dealing with values, right? Integer values. So I'm going to give it int. So let me call the function print. Let me just call it x, something like this, right? Underscore string. That is how I name the file, right? Then what again? Var list. It's going to take a variable argument, var, right? All right, so here I'm going to declare a pointer to character that will hold the string to be printed. Okay, it will hold this string here that we want to print. So I'm going to declare a pointer to a character. So let me call it asterisk, asterisk, let me call it s, right, for string. So let me call it s. So the next thing is I'm definitely going to need a loop at some point, and also I want to keep track of the length of this string here, right? Whatever string is passed to the function, I want to count the string. I just want my function to return the length. I know I'm not printing the length, but if there is need for us to return to use the length, we can just return we can just use the return value of this function, right? So I'm going to declare a variable int I. I'm going to use this for my looping, and then let me call this len, yeah, and I'm going to initialize it to 0. So this will hold the values, or sorry, the number of characters that will be printed. Do you get it? So that's just what this is going to do. So I'm going to declare another variable as well, and this variable I want to declare, I want it to temporarily hold the integer value of a character for processing. Okay, since the character that we're going to take here, we need to process it. Just look at this /n. Where is it? Where is it? The /n. It needs to be processed to be converted to what? To ASCII, to hex. Sorry, right? So I want to declare a variable that will hold this value that I want to temporarily that I want to convert, okay, or I want to process. Okay, so let me call it value, right? So now I have this. So the next thing I'm going to do is I need to call vararg, right? So I think here it should be here. Sorry, so I'll just say s is equals to 1. Don't forget, s is a pointer to a character. It's going to hold the string, right? So I'm calling vararg now, and then I will pass in what? Which variable? Val. And what am I looking for? A string. So, and this is how we look for string using vararg. You simply use what? Asterisk car, isn't it? Or that's a pointer to a character. I've already talked about it when we we're talking about variadic function. So now we need to check if s is null, right? Because there are possibilities that what vararg might fetch will be null, right? So I'll say if s is equals to null, then what shall I do? If s is equals to null, then I will point to the string null. So instead, I will just say s is equals to what? I will just say is equals to null here. So now I've considered the case that if s is what? Is equals to null. So the next thing I'm going to do is I need to loop over the entire element of s, whatever s is holding. Don't forget, s is holding what? The characters, right? So I need to loop over them entirely. So I will need to say for, I'm sure I don't need to explain how to loop over strings now, right? So s index I not equals to the terminating number. We've done this several times when we're talking about pointers, right? So this. All right, so this is going to loop over the entire set of characters up to the terminating number. Okay, it will loop up to the terminating number. So when you look at this, we have conditions. It's not everything that we are going to look for in this loop, right? We only want to look for what? For non-printable characters. Or let me say, we want to have a special operation on non-printable characters. We want to look for all characters. Actually, we want to print all characters. But for those non-printable characters, we want to have a special operation on them. That is when we need to print the // and the x and then convert the value into 2 characters hex value, isn't it? So I need to set a condition now. So if whatever s is holding at whatever index it is, if it is less than 32, I'm considering this case now. Did you see that here? It says less than 32 or greater than or equals to 127. Or, right, s at index I is greater than or equals to 127. So now I've considered the condition, right? I've considered the condition. So what should happen if this is true? If this is true, this is when we are asked to what? To print a / and then print x. Isn't it? Just look at this here. Print / and then print x. So now I will just call my putchar to print a / for me. So I just say putchar and then I will add the /. But in this case, it's not going to print it. We need to escape it, right? So I need to add an extra /. So the next thing is, after printing the /, what else? We need to print the value x here. That's what the instruction says, right? So I will now say underscore putchar, and then I will pass in the character x, isn't it? So now I have comma and // and x printed. And don't forget, I've already declared this variable len, which I want it to keep track of the number of characters printed. So now I have 2 characters printed, so I need to increment len 2 times. isn't it? So all I need to do here is I'll just say len is now equals to len plus 2. So now I've updated len 2 times, isn't it? So the next thing is the value that I want to convert. Now don't forget I've declared this value here, and this value here, like I said, is a variable that will hold the value, right? That will temporarily hold the value in which I want to process, or I want to convert to hex, isn't it? So now I will just say value is equals to whatever is at that index I. So now I have whatever is at index I stored in value, and I can now convert this value now into hex because it is holding what? The value here, whatever s index I is. I just hope you understood this condition. This condition here is stated from the question, and we are told that if the condition is true, we should print a backward slash and then x, which I did that. And because I'm keeping track of the length of characters that I printed, so that's why I add len plus 2 here, right? And whatever the value of s at index I is, I want to store it in value here. So this is a temporary location, isn't it? So the next thing I need to check now is if the value here is less than 16. If value, that is the value I want to convert to hex, if it is less than 16. If it is less than 16, then definitely it can be represented in hexadecimal, right? That's why I said less than 16. We know hex is from 0 to 15, right? So if it is less than 16, don't forget here they said what? 2 characters, always 2 characters. And we saw something here. Where is it? Yeah, as you can see, 0e. So it is in what? 2 characters. So when you look at this from 0 here up to 15, that is up to f, right? There is 0 before each character. So I need to call putchar to print this 0 for me first, right? So I will now say what? I will now say underscore putchar, and then what? I will now say 0, right? Don't forget, I'm converting the 0 into hex, into character. That's why I put it in a single quote, because putchar cannot print it if it's a digit, right? So what else do I need to do next? So the next thing I'm going to do is I've printed a character, and don't forget I'm keeping track of the characters I printed. So I will now say len plus plus, isn't it? Because I have what? Another character printed. Anywhere I use putchar, I'm going to increment the value of len. Do you get it? So now I've done this. So the next thing I need to do now is, since I have the 0 printed, just like this in this case, we have the 0, right? We have the 0. So now we need to convert our value to these values here, these characters A, B, C, D, E, and F, or F. Okay, we need to convert it. So all I'm going to do here is I'll just say len is equals to what? Len plus. So in this case, I'm going to need a helper function. Okay, I'm going to need a helper function, and this function I'm going to need is just that the function should convert whatever this value is into hex. So we've written a function already to convert to hex, right? So I'm going to copy that exact same function and create another file for it. So for now, I don't have the function, so let's just call the function here. Okay, let's just call the function. So it's going to be print here, right? And then this is what? Uppercase, right? So I'm going to consider the hex value for uppercase, converting to uppercase. So I will just say underscore hex, and then what should I name it? Let me just call it extra, right? Extra. So this is going to take what? An argument. And what is the argument? It's going to take this value here, right? So I'll just pass in value here. So what I'm trying to do here is that this print hex extra here is going to take in this value and convert it to hex. Don't forget the function we wrote already on converting to hex. It is what? Taking a variable number of argument, varlist, as its argument. While in this case it is different. It is taking what? A value as its argument. And this value it takes is what? Is an integer. Okay, so that's why we need to create an extra function for this. We cannot refer to that initial function on print hex, because that function takes in what? Varlist as argument, a variable argument, while in this case it is not variable, it is fixed, a value here. This is the value we want to convert. So I'm going to create this function now, and this function I want to create is the same as that of the print hex with just a little modification, and we are going to see that. So now let's put this on hold and let's go out and create the function. So let me call it print underscore we are dealing with hex in caps, right? So underscore, I call it extra, right? Extra.c. All right, so here I need to include, not that I said I wanted to copy, right? So let me just copy it, printf underscore hex. Sorry, is it print? Okay, print underscore hex. Wait, what am I doing? Hex, right? Dot c. All right, so I'm just going to copy the whole of this. This is the function that will perform the task, or that will perform the work for us. So let me open it again, extra, and then I'm going to paste it here. All right, so now I have this pasted. So the next thing I'm going to do is, like I said, there is a little modification, right? And the modification here is that when you look at this, this is taking a while list as argument. While in this case, I want this to take in what? An unsigned. Oops, sorry. I supposed to move on here. I thought my cursor is here. So here, this is going to take in what? Instead of an unsigned int, it's going to take what? Sorry, instead of a while list, it's going to take an unsigned int. Right? So I'm going to call whatever it is, let me call it no. Okay, so here I'm going to give it a name. What's the function name? We said extra, right? Underscore hex extra. Yeah, this is the function name. So these are the modification we need to make, and here in this case I need to delete this part here. Yeah, so that's all we need about this. Okay, we have everything now. Do you get it? So this function is going to perform what? A conversion. So it's going to take in an unsigned int number and convert it to what? To hex. So it means this function can convert our value now to hex, right? So let's go back to the initial function. Oh, sorry, before that, let me copy the prototype to this function. Let me not forget. So copy. So vi main.h, right? So I need to paste it here. All right, so let's go back to that file. Print what was the file name? Exclusive string. Yeah, so here I now have it. So don't forget, our print hex extra is returning what? A length. It is returning counter, and that counter, don't forget, it takes in what? Or it returns, it is holding what? The length of the string that is being printed. So that's why here I said len. That is whatever the value of len is at this position plus whatever this function is going to return, not print. Take note. Since the function is going to return a counter, which is counting the number of characters, so that value will be added to len. So and now len will now hold the exact number of characters being printed. And this print hex extra here is going to convert whatever we have at this value that is less than 16 into what? Into a hexadecimal. So that is how we will have this what? A printed. Is it A? Is it B? Is it C? Is it D? Is it E? Is it F? That's how we have it printed. Okay, so as you can see now, we have 0A. We have two characters. It says uppercase. That's why I considered the uppercase hexadecimal function that we wrote. I believe this is clear, right? So the next thing we need to do here is what? Else. The else part here. Else, that is if what? If the value at I, at whatever index of I, is not part of this condition, doesn't meet this condition here. So if it doesn't meet the condition, it means what? It means we can print the value. So I will just print it. So I will just say put cap, then print whatever value at that position. That's all. So there is no need to do any special operation on the value, because this condition is not true. It means it is not printable. It means it can be printed. So since it can be printed, now print it using put cap. Okay, so after this, don't forget we need to increment our len. So I'll just increment len. So that's all we need to do. So here I will just return my function as well. So I will just say return a len. That's all. Okay, so now let's document Betty for this. I think that's all. All right, so let me copy the function prototype for this as well. If I forgot. All right, so let me open my main.h again and paste that prototype. So I'm going to do that here. So now I have it, exclusive string, right? So we cannot test the function now because, like I said, we've not written this function here, int printf. So we cannot test it. So now we are just writing the functions like I explained earlier. We are going to write the functions first. After writing the function, then we create the main file or the control file which is responsible for fetching all these functions and performing exact operation on them. Okay, so indirectly we are done with this task now. Okay, we are done with the task. Okay, so let's move on to task 6. All right, so this task 6 here says we shall handle the conversion specifier p here. What does p print in printf? It is used to print address, right? Pointer, right? It is used to print address. So let's see how to develop a solution for this. So let me create the file. Let me call it print, what should I call it? Pointer, right? Let me call it pointer.c, isn't it? So let me include my main.h. Right, so now we need to develop what? The prototype. So I want this as well to keep track of the number of characters I want to print, or that is printed. So I will return an int, right? The return value should be an int. So let me call it print underscore pointer, right? So it's going to take a variable argument. So var list, I'm going to call it val as well here. All right, so what do we need to do here? So the first thing I'm going to do is I will declare a pointer that will hold the pointer value to be printed. Okay, so this p, don't forget, we are dealing with pointers now. So I'm going to create another pointer that will hold the pointer value that I want to print. What happens when you use printf with %p? It prints address, right? In hexadecimal, you see 0x and then some random values. That's how it prints it, right? 0x random value, 0x random value, isn't it? So now I want to create a variable that will hold that value for me that I want to print. So I'm going to say void asterisk, let me call it what should I call it? P. Okay, why am I using void? It can be anything. It can be a character, it can be an integer, right? That's why I'm using void here. So the next thing is I need to declare a variable as well, a pointer s, which I want it to point to the nil here, this value nil. Why am I doing this? You understand why I did this, but for now, why do I declare this variable here? So I want to initialize this pointer s to nil, okay, and this will be used if the pointer value is null. So in any case, if the pointer value is null, the value that the pointer is pointing to, if it is null, I can simply call this variable here, or this pointer here, and it will print nil for me. Okay, you are going to see why I did that. Okay, so the next thing I'm going to do here is I will declare a variable for my looping. I think for now that's all we need. So let's begin doing something here. We've declared this pointer p, and we said it is going to hold the value that to be printed, right? So I'll just say p is equals to now var arg. I'll call my var arg, and then I will pass in what? Val, that is the variable that holds the argument, and then I'm looking for void, right? So any character, it's going to print it. Okay, so that's also what I did here. So the next thing is, what if p here is null? That is, what if var arg here, the argument var arg fetches and store in p is null, right? If p here is equals to null, then what should we do if p is equals to null? If p is equals to null, we are supposed to print null, right? If it is null, we are supposed to print null. But I'm not going to just say print or putchar null here in this case. If I should print putchar now, if I should print null now, I need to call putchar, because I cannot use printf in this case. I need to call putchar and then pass it n, and then call putchar again, pass it I, call putchar again, pass it l, call putchar again, pass it the bracket. And this is not what I want to do. So that is why I created this pointer here, s, which is pointing to this. So all I'm going to do here now is just loop over this s, and for each iteration print the value at that index. So I'll just say I equals to 0, right? S index I, right, not equals to the terminating null byte, isn't it? Then I plus plus. So this is going to loop over the entire s, and this s is holding what? S is holding nil, right? So I'll just say putchar whatever is at s index I. So this way I will get nil printed. That is, if p is equals to null, if a null value is fetched by var arg, then we are going to get what? Nil printed. This s here is because I have already created a pointer to a character s, and it holds the nil that I want to print. Do you get it? So after this, I said I want to keep track of the length, right? I want to know the number of characters printed. So I can simply just say return what? I. Because what? I is for the iteration, right? I is for the iteration. So for each iteration, I is going to give us the number of characters that is printed, isn't it? So indirectly, I here is holding the number of characters that has been printed. So that's why I just say return I. Okay, so else, the else part here, what should we do? You know that the value here, the p that we want to print, right? The value that we want to print. All right, so now what do we need to do here? This p here is a void. It means it can take anything, right? It can be a character, it can be what, an integer or whatever, right? So I need to process this value of p. What I mean by processing is I need to convert it to hex. Whatever the value that is stored here, it needs to be converted to hex because pointers are in hexadecimal, right? So for me to do that, I need to cast this p because currently it is a void, right? And what we get as what, as the address, is not a void. It is in form of an unsigned long integer, right? So I need to say unsigned. I need to cast it now. So I need to say unsigned, that is the value or data type I want to convert it to, right? Unsigned long int. And then what am I converting? I'm converting p. Whatever p is holding, convert it now to an unsigned long int. Whatever the data type of p is, currently it is void, right? At this point. So when you add this, it is casting it now to an unsigned long integer. Do you get it? So this way I can be able to print the value in hex. If you don't cast it, you cannot print the value in hex because from here p is void. Okay, so here let me just declare another variable to hold whatever this is going to return. So let me just call it shall I say a? Let me just call it a is equals to this. So here let me declare the value a, right? So here I will just say, where is it? Yeah, here I will just say long int a. So that's all. So now I've declared the value, the variable a, which is going to hold the casted value of p, right? So the next thing we need to do is, if you can remember, whenever we're printing address, 0 comes first, then what? Then an x, right? So we need to call putchar to print that 0 and print the x for us before we convert whatever a is holding now into the hexadecimal value, right? So I now call putchar. I say putchar, and then I want you to print 0 first, right? And then I want you, putchar again, to print what? To print x, right? So this is, or let me say, these are the characters that we first see before printing hexadecimal value, or sorry, before printing address, right? When we use pointer, we are printing address. Before we print address, we normally see 0x and then some random values, 0x again random value, 0x again random value. So that's just what I did here. I first printed the 0 and the x. Now the next thing we need to do is to convert this a now into what? Into hexadecimal, right? We need to convert it now to hexadecimal. So now it is in form of an unsigned long int, right? So since it is in form of an unsigned long int, convert it to hex, right? Convert it to hex. So we are going to do the same thing as we did in the similar question here, similar task. We are going to call that function that converts to what? To hexadecimal, isn't it? We are going to call the function that converts to hexadecimal, right? So in this case, I will just call the function. I've not created the function yet, so I will call it hex. And the other one, we'll call it capital hex extra, right? So let me call this lowercase, and then I'll just say extra. So this is the name of the function. And what should I pass to this? I'll pass in a, because a is a value that I want to convert to hex, right? So now I have this. Let me declare another variable to hold the return value. So b is equal to this. I named it b. So here I need to declare b, right? So it is an integer. So let me just say b here. Why is b an integer? Because b is going to hold whatever this is going to return, right? So, and print hex, don't forget, it returns what? A counter. What counter? Counter counts the number of characters being printed. So it is an integer. That's why my b is what? An integer here. So now let's go and create this function here. Let's go and create the printf hex extra. Okay, so let's go back. So let me say vi, let me say print underscore hex, right, underscore extra dot c, right? So here I forgot, I need to copy it. I already have it. So vi printf print, sorry, what is the name? Hex, right? Hex. Okay, I missed the t here. Hex dot c. All right, so I'm just going to copy this, right? So it is the same thing. It's just that in this case as well, we need to make some modification. So hex extra, right? underscore extra dot c. Right, so here I just need to paste this. So it's just that here in this case I need to change this print hex underscore what was the name? Extra, right? Underscore extra. That's the name. And here I need to change this, instead of a var list, now it is taking what? An unsigned long int, right? Unsigned long int. So it is going to be num here. So here as well, my I here is going to be what? Is going to be a long int, right? And the counter as well is going to be a long int as well. So my array here is also going to be a long int. And then what? This part here, I'm supposed to delete it. This, because we are not dealing with variable arguments now, right? I think that's all right. Yeah, so here it's supposed to be an unsigned long int as well. Because what? Because num is an unsigned long int. So this has to be an unsigned long int. So here, instead of size of int, I will just say size of, size of long int. So that's just what we need to do to make this adjustment. Okay, so we are done with this. All right, so let's go back to our code. It is print hex.c. That was okay. This is the file, right? Is this, which one are we working on initially? Pointers. So print pointers. Yeah. So now we have the function that will do the conversion. This function here, print hex extra, is going to be called, and the work of this function is to convert this a here, which is an unsigned long integer. It's going to convert it to hexadecimal. Okay, so and whatever this print hex is going to return is going to be the length of the characters in which it converts, right? And it's going to be stored inside this variable b. So now this b is holding what? The exact number of characters being printed by this function here. Okay, and the function work is to convert a to what? To hexadecimal, right? And this a here is gotten from this here, the p. This is the string that is passed to the function. Okay, it is first converted into an unsigned long integer. I hope you understood what I just did here. So the next thing we need to do is simply to return the function, right? Like I said, it is returning an integer, and I want to return the total number of characters being printed. So I just say return. Here, don't forget, b is what? Holding the characters that has been converted to hex, isn't it? So I just say b. So b has what? The total number of characters converted to hex. But these are not the only characters that we have. We have this printed as well. This putka 0 and x printed. So we have two characters printed. So I'll just say +2. So this is what my function is going to return. Okay, so this is simply how to write this. So let's document Betty. So that's all. Let me copy this prototype. I forgot to copy the prototype of the helper function we created as well. So let me go to my main.h. So print or paste this. Right, so I think that one is something like int print what? Hex, right? Print hex underscore extra. I think that's the function name, right? And it takes in what? Unsigned. Is it unsigned? Unsigned long int, right? Called what? No. Let me just check to confirm. Okay, the prototype. So let me say vi print underscore hex. Yeah, unsigned long int. Yeah, that's the function name. It's correct. So now we are indirectly done with this as well. We've written a function that will perform this operation. Okay, so the next thing we're going to do is to solve on this task 19 here. Sorry, task 13. Okay, I hope this is clear. Like I said, we are not writing the main code now. We are not writing the control code now. We are writing the functions first. It is when you have the function that the control code will be able to fetch the functions and perform whatever you want to perform. So let's finish writing the code first, okay? So this here says we should handle the following custom conversion specifier. What does this does? R here. What does R does? Is it rotating? Okay, no. R here, this capital R prints the root 13th value of a string. Okay, this placeholder here, R, small letter R, is used to print in reverse. So we have already written a function to print string in reverse, right? So don't expect me to explain this. Okay, so I will just go and write the code now. I'll pause the video, I'll write the code, and then we continue. Okay, but before that, let me create the file. So what should I call the file? Let me call it print reverse, right? So let me call it reverse string or whatsoever .c, right? So now let me pause the video and I will continue. All right, so this is the code. This code here is responsible for printing string in reverse. Okay, so don't expect me to explain this, please. We've already done this. Okay, so now the next thing I need to do here is I need to copy the prototype of the function. Let me copy it and let me take it to my main.h. Main.h, right? So let me just paste it here at the top and then paste. Yes, so I'm done with this. So we are done with this part now, task 13. So task 14, it says handle the following custom conversion specifier root 13th string. As you can see, I skipped from 6 here. From task 6 I went to task 13. I have a reason for that. Okay, I have reason for that. I want us to finish with these characters here, these handlers here, the one with p, r, i, j and whatsoever, before we start dealing with characters like minus, plus, hash and whatsoever. If you look at the questions very well on the internet, you realize that from 6 to 12, from task 7 to task 12, it involves all handling such type of characters, either plus, hash or whatsoever. So I want us to finish dealing with these ones first, then we'll go back and deal with that. Okay, I forgot to explain this earlier, sorry about that. All right, so now we are going to print root 13, right? This will handle root 13. I've already explained root 13 when I was talking about more pointers, arrays and string. I think it is the 8th task. I can remember task 8. I've already created a video on that. Is it pointers? Yeah, it is on pointers, definitely. So I'm not going to explain this code again as well. Instead, I will now write the code. I will pause the video, write the code, and then we'll continue. So what name should we give this file? Let me call it print root 13. Right, I think this is fine. .c. Okay, all right, so this is the function that converts whatever to root 13. So like I explained, root 13 is an encoding scheme, right? One of the ways to encode strings, right? You can use root 13. So I have the code now here, right? So now I need to copy the prototype. I'm not explaining this because we've done this already. Okay, I've already said this before in the beginning of this video. I'm not going to explain any function that I'm sure we've written it. Instead, I will just get it, or I will type it, or whatsoever. I'm not going to explain it. Okay, so I have this. Let me copy the prototype. Now I need to take it to my main.h. So main.h, right? So I need to paste it here. All right, so paste. Okay. All right, so we are done with these tasks now. So now the remaining task we need to solve is from what? Task 6 to task 12. So for now, we can proceed and create our test file, or let me say main function that is responsible for controlling all these things here. Okay, but before that, let's run Betty on our code. I'm sure there are places we'll be having problem with Betty during description maybe. So I'm running Betty on all the .c files. Oh wow, so whoa. Wow. So it says code indent. Wow, these errors we are having, some of the indentation errors here, we are having them because we copied from the terminal to another file, right? That's why we're having this this error here. But in your own case, since you are going to type it, there will be no error here. It's when you look at this, all these errors are code indent, spacing and indent. So instead of you to use space, instead of you to use tab, you're using space. That's where the errors are. So please, you can just fix this. I'm not going to take time fixing this. Okay, so I'm sure Betty is your friend now. So initially I thought we'd be having description errors, but we ended up having spacing or tabs error. So I'm not going to fix this now. So we are done with this. Okay, please fix the Betty error. Okay, so what else do we need to do? Now we need to create the main function or the control function. How do we do that? So what name should we give this file? Let me call it or since I'm not going to work on it now, let me just create the file. Let me call it printf, right? Since it is printf, right? So let me call it printf.c. So now I've created the file. So before we work in this file, we need to go back to our main.h, right? We need to go back to our main.h, and what we need to do here is we need to create a structure, right? We need to create a structure. We know what a structure is. Why do we need the structure? It's because I want whenever a placeholder is encountered, then call the function that is corresponding to that particular placeholder. So for us to do that, we need a structure, right? So let me declare the structure here. This is one of the uses of the header file, right, for structures creation. So let me call it type def. What should I call it? Let me call it format. Let me call it format, since we are dealing with format, right? That's what so let me call it format. The name of the structure is format. So here, sorry, it should be this. So the structure here is supposed to take in what? Two members. The first member is what? Supposed to take note or to take hold of what? Of the placeholder, right? And the second one is responsible for what? Holding the function associated with a placeholder. Isn't it? For example, now, if the format is what? Let's say %s. We know %s print string, right? So the first member is going to handle %s, while the second member is going to hold the function that is responsible for printing the string, since %s print what? String, right? So here I will say pointer to id. Why am I using character? Why am I using character? Because I'm looking for what? Percentage something. So it is what? It is a string, right? So I'm calling it id. So the next is what? Is the function pointer. I will say int. Why am I using int? Because when you look at this here, like where is it? Yeah, as you can see, the return type of this function is int, right? And I'm going to reference this function, so that's why I'm using an integer here. So let me call it f. The function pointer name is what? Is f. So it's going to take an argument, okay? It's going to take an argument. So I'm not going to add void here, since it is going to take an argument. So since I've typed def it, let me give it a name. What should I call it? Let me call it match, right? So the name is now what? Is now match. So we need this function pointer, right? So this structure here. Like I said, this ID here will handle the placeholder, and this one will handle the functions that we created. That is these functions here. And these functions are associated with what? With different placeholders, right? So this structure is important in this case. Okay. All right. So let's go back to the file. So vi, that is printf, right? .c. All right. So here I need to include my main.h first. Main.h, right? So after that, then what again? Let me copy the function prototype. I can't remember the prototype. Yeah, this is the prototype, right? So copy and paste here. All right. So now I have this. So what do we need to do? Before that, let me document Betty. So the function name is what? All right, so what else do we need to do? So here, in this case, if you can remember, we've created a structure called match, right? So now we need to create a variable that is going to store this placeholder and also the functions associated with this placeholder. Okay, so what was the name we gave our structure? I can remember I typed def it, I called it match, right? So match, so what should be the variable name? So now this is the data type, right? Match is not the data type. So what should be the variable name? We call it m. Okay, so it is an array. So it is going to take what? It is going to take the placeholders and also the functions associated with each placeholder. So now let me open this here. All right, so what should we do first? In this case, the first case we considered is what? Is %c, right? So I will need to consider %c. Let me do something like this. Yeah, %c. So all I need to do here is create another array. Please, I'm sure this is not something that you are just seeing it for the first time. We've already solved we've already done questions on structures and function pointers as well. Okay, so I don't expect you to have any problem with this. Okay, so now I'm going to consider %c, right? It is the first one. So what should be the function to be called when %c is encountered? When %c is encountered, what was the name of the function? Let me open this. It's another terminal. I'll be able to see the functions we created. So let me open my main.h. All right, for %c, sorry, for c, we name it what? What do we name the function? Car, right? I think it is printf_car, isn't it? Let me just check to be sure. So vi, what is the file name? Print underscore car, right? Sorry, let me check. Vi, what is the name? Print. Okay, print underscore c.c. Okay, yeah. So let me check print underscore c.c. Okay, yeah, printf underscore car. We named it printf underscore car. All right, so let's go back to our main.h. So here I'm going to call printf underscore car. That is this function here. That is the name of the function, isn't it? So I'm going to copy this and then I'm going to paste this here, right? So this is going to call the function, right, associated with %c. So the next one is what? Which function? %s, isn't it? %s. So I will type in %s here, %s, and then the function that should be called in association with %s, which is what? The function name is printf underscore string, isn't it? That's the function. So paste this as well, isn't it? So the next one is what? Is percentage. That is this part here, right? Percentage, isn't it? So when you see percentage, call which function? The function we created associated with this is what? Let me check. Not this. Associated with percentage is something underscore. Is it 37? Yes, print underscore 37, right? So I'll just say print underscore 37. So I'm calling the function that is responsible for handling this placeholder. So the next one is what? After that, the next one is what? Is %d and %i, isn't it? %d and %i. So this is going to be %d. So what function is responsible for handling %d? We have print, this is it, underscore dec, right? %d for decimal, right? So print underscore decimal, right? And then what again? We have which one again? %i, right? %i. So which function is responsible for handling %i? It is called what? Print underscore int, isn't it? So it will be print underscore int. Okay, so I'm going to pause the video here and I'm going to continue all these things. Okay, I'm sure by now you understand what I'm doing. So I'm going to finish it and then we continue. All right, so I've already created the array here. Okay, I've listed all the placeholders and also their corresponding function. Okay, so now the next thing we need to do is this. We need to declare our var list since we're dealing with variadic function. Now, as you can see, format here, this is what a variadic function. So var list, I'm going to call this args now, not val anymore. Okay, so what I'm going to do here is I'm going to declare a variable which will hold the length of the characters, and I'm also going to declare my I, which I'm going to use for the looping, right? So I'll just say int I, right? And then let's say len here, let me call it len, and then it's equals to what? Is equals to 0. Okay, or I'm not going to use this for the looping. Let me just initialize it to 0. I initially wanted to use a for loop, but I'm not going to use a for loop now, so I'm going to use a while loop. So that's why I'm initializing the value of I outside the loop. All right, so what's the next thing we need to do here? The next thing we need to do is we need to start, right? So what is the variable name? Is args, right? And what are we looking for? We are looking for format here, right? Don't forget the argument that args, the second argument of var start. Sorry, I misspelled this. The second argument of var start has to be what? The variable or whatsoever that comes before what? The ellipsis, right? And in this case, it is what? Format. So I'll pass in format here, right? So var start. So the next thing we need to do here is check what format is holding. Right? We need to check what format is holding, because if you remember, when you use printf, what do we normally do? You pass in % whatsoever placeholder you want, and then you pass in what you want to be replaced with that placeholder, right? So firstly, it has to check which placeholder is that, right? It has to check which placeholder is that. So what I'm going to do here is I'm going to set a condition to check what if this format here that the user pass is something that is null, for instance, if it is null. So I'll just say if format passed by the user is equals to null. So this is not the only condition I want to consider. Or what if the user pass in just a single % sign, no S, no C, nothing, just S, sorry, just percentage. Ideally, we're expected to have percentage something, right? Percentage C, S, or whatsoever. But the user just passes percentage. So it doesn't make any sense, right? It doesn't make any sense. So we need to check that as well. So I will say, or I will open a bracket. I will say format index 0, right? What is index 0 of format? It means the first character, which in this case, it is what? It is percentage. If it is equals to percentage, right? It is checking if the format at index 0 is equals to percentage, and also what comes after it, right? And also format index 1 now is equals to the terminating null byte. So this is going to check, right? This is going to check if format is null. If it is equals to null, then this condition will be executed. Or if the first parameter of format is percentage, yeah, it is percentage. So we are expected to see either C or S or whatsoever after the percentage, right? Okay. So, and also if percentage, if format index I is equals to terminating null byte. So if format index I is index 1 is the terminating null byte, it means after this percentage sign, there is nothing else the user passed, right? It is just the percentage sign because this is a null byte. So if this condition is true, then we are going to return something that should indicate it is an error. So let me just return a -1. I hope you understood what I just did. This is just checking to ensure that format is not null, and also the character that comes, and also the user did not enter just a single percentage sign. Okay, instead percentage something. I believe this is clear. All right, so now the next thing I'm going to do here, I'm going to create my while loop. So I will say while this loop is going to loop over the format entirely. So format, right, index I, isn't it? It's not equals to the terminating null byte. Sorry, it's not equals to the terminating null byte. So as far as format index I is not equals to terminating null byte, what should we do? When you count here, we have how many elements in this array? We have 14 of them, right? We have 14 elements here. So I need to consider all the 14. Okay, what should I do now? I want to declare a variable now that will help me in looping over this entire array. So here I will declare another variable. Let me call it G, int G instead, right? So I'm going to use it for looping over the array, this particular array here. Okay, so what should we do now? We have 13, sorry, we have 14 of this, like I said, so I can initialize my J to be equals to 13, right? Why is it 13? Because if you count from 0 to 13, that's when you get 14, isn't it? So I will now create my second loop. This loop is going to loop over this. This first while loop is looping over the format, as you can see, right? And this second loop, I want to loop over this. So it means for each iteration of format, whatever is in format, look for its corresponding value or whatsoever it is inside this match here, M. Okay, so that's why I'm trying to create this loop. So J is greater than or equals to 0, right? So with this, I'm targeting how many? 14, from 0 to what? To 13. Okay, I'm targeting from 0 to 13. So what I'm going to do here is this. Okay, yeah, it's correct. Okay, all right, so here I initialize my J to 13. So what is in index 13 here? What is the 13th element? The 13th element is this percentage P and its corresponding function. So it is going to start the loop from the last element in this case. Okay, it is going to start the loop from what? From the last element. Do you get it? So here inside this while loop, I can just say J minus minus for now. Okay, so I'm starting the loop from the last element, then I will be going backward. That's how I'll keep going. Okay, so now I have this. So what I need to do next is I need to now check what is in index 0 of this particular array here, right? I need to check the index 0. Don't forget, in each index in this array, we have ID and we have the function, isn't it? We have the ID, we have the function, right? So I need to check if what is in M, don't forget this M here is representing this array now, right? If what is in M index J, sorry, index G. So in this case, what is J? 13, right? So it's targeting the 13th array here, the 13th index, right? So if what is at that index dot ID, we are checking the ID part now, which is this percentage C, percentage S, percentage, this percentage, because ID is responsible for storing the percentages. the percentages, right? ID is responsible for that. Okay, so I will check ID index 0. Is it equals to format at index I? That's simply what this condition means. Whatever is in M index G, assuming G is 13 for the first iteration, so it's considering this part. Now, let me maximize this. It is considering this percentage P part here, right? That is the 13th element. So, .id, what is the ID? The ID is this, percentage P, right? Okay, so in this ID, what is in index 0 of the ID? The index 0 is what? Percentage, right? So we have percentage in index 0 of the ID. So this is checking if it is equals to format I, right? If it is equals to format I, then what? It means it has found a percentage character, right? That is just what this means. If it is equals to whatever format is holding in its ith index, if it is a percentage sign, then it means this condition is true. Isn't it? This condition is true. And also, here, sorry, and also, this is not the only condition we need to check for. We can also check for this. And also, if M at index G, right, dot, in this case, ID 1, index 1 now, we are checking for index 1, right, is equals to format index I plus what? Plus 1. What this simply means is this. The first condition here is checking for the percentage sign, right? If this is true, and also MG, the same M index G, which is the same array here, the same member of the array here, its ID index 1 now, in this part here we considered what? Index 0, right? Now we are checking for what? The index 1. That is the character that comes after the percentage sign, which is this. This is index 1, right? So it's going to check, is it equals to format I plus 1? Initially, format I, we said it is percentage, right? When it's compared with this one, it finds that, okay, the format I is percentage and ID index 0 is also a percentage, so a match is found. So now it will move and check what character comes after the format index I, right? If the character that comes after the format index I is the same as this, then it will jump into this loop. Sorry, this conditional statement here. It will jump into this statement. I believe this is clear, right? So this is just checking for what? For the placeholders. Particularly, this is checking for the placeholders. Okay, it is checking for the placeholder. So what should happen if this condition is true? If this condition is true, it means it has found a what? A placeholder. So what should we do? I've declared my len already. I want my len to keep track of the number of elements, right? So I now say my len is not equals to len plus what? Don't forget we have the function part, right? We have the function part. So how can I access the function part? The array name is M, right? So I'll just say M at what? Index G, the same index G. But in this case, I'm going to say dot F. Why F? Because F is the name of our function pointer, which is responsible for storing the functions associated with each placeholder. That's why here I said dot F. And if you can remember in the declaration of this structure, I created what? An opening bracket. There is no argument. I said it is not a void, but we are going to pass an argument to it. So in this case, we are going to pass what? The variable that holds what? Our argument, which is args, right? So I pass in args here. Okay, I believe this is clear, right? So the next thing I'm going to do is to increment the value of my I, right? I need to increment the value of I. I need to say I is equals to what? I plus 2. Why am I saying I plus 2? Because already I here has checked for what? For its current position, and also this I plus 1 here has checked for what comes after the percentage sign, right? Format index I, assuming format index I encountered a percentage sign, right? And format I plus 1 is checking for what comes after that percentage sign. You see we have what? Checked for 2. So that's why here I'm saying I plus 2. Now I'm updating my value of I to what? I plus 2. So this means that if this loop ends, the value of I should increment 2 times before checking for the condition, because we've already checked for what comes after the percentage sign in this format here. Okay, I believe this is clear. So that's just what this means. So the next thing we need to do is this. Here I need to do something here because I just realized we are going to have a problem. So let me call this here. Let me just say here. I'm just trying to create a label for this particular code. Okay, I'm creating a label. So here, I will just say, let's say, at this position, I will say go to here. I'm just creating a label here. This is just like a loop. It is acting like a loop, but it is actually not a loop. So what this means is, as after printing this, if this condition is true, after executing all these lines here, then the loop or the control should go back to the while loop again. Because we need to come back to the while loop to check if there are other format or placeholders, right? We need to come back to the loop again and check if there are other placeholders. So that's why I said go to here. So this here is just a label I give this particular part of code. Okay, so here when it encounters go to, then it is expected to see something here, right? And the name of the label I gave is here, right? So go to here. So this will jump back to this part here. Do you get it? So if a placeholder is found and if the code has been executed for that placeholder, then come back again to this loop and check if there are other placeholders, because our printf can contain more than one placeholder. So that's why we need this part here. Okay, I believe this is clear, right? So the next thing we need to do is this. Now we are done with the while loop. Here, I think that should be all right. All right, so here, what do we need to do now? We need to now print whatever the format I is holding, right? We need to print it. All right, so the next thing I'm going to do outside this loop is I will now print what format I is holding. So I'll call my putcar to do that, and then I'll say, wow, I'm so much tired, the video is even taking long. All right, so I'm printing whatever format I is holding at that position. Okay, this way I'll be able to print whatever is associated with what, with the placeholder, right? So the next thing we need to do is what? I need to increment my I because of this loop here, this I, this format I, right? This is a while loop, so I need to increment I. And then what again? After printing this, putcar is going to print the format, right? And don't forget, I'm keeping track of what? The number of characters printed. And len is responsible for holding those that number of characters, right? And here I have called putcar. So it means I'm having now an additional character printed. So I will now call my len and say len plus plus. Okay, so that's all. So here I will just say var underscore end, and then I will add my what variable, which is args, right? And here I will just return, I will just return my len, which is the total number of characters being printed. I believe this is clear, right? This is function pointers. And I've taken my time and I've explained function pointers clearly. So you are not supposed to be having problem with this part here. I've already taken time and explained this as well just now, which I'm not supposed to, but I've explained it. Okay? If you go back to the structure, you realize that I've created a what? A function pointer, which is f, and it's going to take an argument. That's why I am able to pass args to this now. Okay? All right, so now let's save and exit. Is there anything that we've not, wait. Yeah, I think we have this prototype already in our min.h, right? We have it. Let me have a look of my min.h. Okay, where is it? Yeah, we already have it. So that's all we need about this. Okay, we can now test our function. All right, so let's go back. Let me minimize this again. So let's go back, and where is the test file? Okay, I created the test file here. Yeah, test function. So let me copy this. This is a test file. It is already on your intranet. Okay, it is in your intranet. All right, so copy this. So, but mind you, you are not supposed to push including this main.c file. The purpose of this file is just to test. Don't push it to your GitHub. Okay, don't push it to your GitHub. It is just for testing. So it is advised you create a separate folder and add this main.c file if you want to test it. But after testing this, I'm going to delete it. Okay, I don't want to push with this. Okay, all right, so let's now compile the program. Now we've created the test file. Let's compile now. So where is it? This is the compilation command. They've given us a compilation command here. So we are compiling all the .c files, right? So here, let me call it printf. So let's press enter. Whoa, why am I getting this? Okay, no such file or directory stdarg. Okay, I have problem with my main.h. So I misspelled stdarg. So let me do that. vi main.h. I misspelled it. Yeah, stdarg. Yeah, okay, that's all. I just hope this should be better. Don't forget, in your code here, document your what? Your structure here. Don't forget to document it. Better document it. All right, so let's gcc again. Also, please, anywhere you used malloc in the code, we always consider the condition if the malloc fails to allocate, right? Please, in this case, we are going to get rid of all those conditions. So just leave it, okay, as malloc has allocated the memory. Remove that if dash is equals to no return null. It will not work when we try to compile. I just run the compilation. I realize that's the mistake. So get rid of all the null, okay? In any way use malloc, please, in all the functions. So get rid of that condition that says if so fails, return null. Just like this case here, this one here. If array, as you can see, it says if array is equals to no return null. So just get rid of it, okay? So all right, so now let's compile again. Don't forget, remove those conditions, please, okay? All right, so compile. So it has been compiled, but definitely we are going to get a segmentation fault, okay? So slash printf. Whoa, so as you can see, we're getting a segmentation fault, but let's see, do we have anything printed? Yeah, we have some things printed here. Let's just look at the output here. We have some of them printed, not everything actually. Let's see. Wow, I cannot debug this thing. Okay, so as you can see, we got from this point up to this point printed, just this remaining part. So definitely there is an error somewhere, there is a mistake somewhere, okay? So possibly if you're going through the video, you might be able to see it, but let me show you the main printf I created, the main folder for printf. So let me go out of this and then go to printf. All right, so as you can see, I have everything here. All the files are here, even though the names are not the same, but all the files are here, okay? So I'm going to run it here. Did I copy the compilation command? Okay, not this, sorry. All right, so let me delete this. I want to compile the program. So where is the compilation command? Let me copy this. Yeah, and let me compile using the same command here. Why am I not seeing that? Let me just go back here and copy it. Compilation command. All right, so copy and then paste here. Oops, I forgot to give it a name. Let me call it print. All right, so as you can see, it has been compiled. So let me run it. Print. So did you see that? Like I said, we are expected to have a segmentation fault. Okay, we are expected to have it, but it's not normal. I don't mean it is normal to have segmentation fault. Okay, so here, as you can see, I got the exact output. This is the main printf folder I created for my project. This is the main printf folder, and I've already wrote this code. So as you can see, it is working here. So here on this Vagrant, I don't know what the problem is, but possibly if you're going through it, you might be able to see what the error is. But as you can see, it is working here. So I will share my file with you as well. Okay, I'll drop a link to this file so you can get the files as well. But I just hope I've explained to the extent of you guys understanding what we're trying to do, even though as you can see here, we've not gotten the exact output, but at least we know what you're going to do, right? So I've explained to the best of my ability now. Okay, so possibly in the next video, we are going to consider the remaining part. That is from task 7 up to task 12. Okay, so before that or after that, if I'm able to check for the codes in this file and figure out the problem, then I will share with you. So for now, we're going to stop here. So thank you very much and thank you for your time.